Okay, so I think we can start it now. Welcome to BSE 452 Energy Efficient Building, and I'm Dr. Huan Zhao. So before starting, I can give a brief introduction about my background. I'm now the research assistant professor in BEE, and I enrolled 2024, so it's about 2 years I worked here. Before that, I was a research fellow in Nanyang Technological University in Singapore, and I graduated from the Chinese University of Hong Kong with computer and information engineering. So you may find that my background is very complex with the computer science and also the energy management. So my research area majorly focus on the AI for energy management and trading now, and I show you the email address of mine and also the office and phone number. So if you have any question, you are welcome to send me the email. So and if you have some emergency, you can like call me with the phone. So this is the office phone number. Okay. Oh, you may find this information on our website or the department website. So before starting, I would like to show some rules of this classroom. So I hope that we can first of all arrive on time. So if you have something need to be done, so just do it. Okay, you don't need to ask me for permission. So and please ask me if you don't understand, because I know sometimes I may have a low voice or mispronunciation makes you confusing. So just raise your hand and I will directly answer your question. And please keep the classroom tidy. And the most important one, please do your homework, especially the mini project before the DDL. That's very important. Okay, because we normally don't accept late submit. Okay, that's very important. And also for me, I will finish the classroom on time and uh, give a break for each hour. Also, if you send me an email, I will reply you within 3 days. Normally 1 days, but sometimes I may delay for a while, 1 or 2 days. So my schedule for this course is start at 6:35, so about 5 minutes after half. And the first period would be like 1 hour and 10 minutes, and then we'll have a 15 minutes break, and then again 1 hour and 10 minutes. I will try to finish the lecture uh, before 9 and 10, because I know all of you are very tired and need to like take a rest and back home. Okay, and so I will leave like 15 minutes Q&A. I will stay here for actual 15 minutes, and if you have any question, no matter about the course or other things related to the like energy management or building energy efficient buildings, you can stay here and ask me. Okay, any question? Sure. I will try. Is that okay? Uh, louder. So I will try to speak louder. Okay, because maybe I can change the microphone. Hello, is it better? This one is better. I know because that microphone doesn't work well. Okay. So let's start today's content. So in today, I'm going to talk about the fundamentals of building energy management, the targets, system, and the methods. So in today's course, first you are going to learn the fundamental objectives of building energy management and the key factors influencing the energy performance in the buildings. So what is the energy efficient building during the operation? And also you will learn the architecture and the operational function of a building energy management system. So the platform that's to actually do the energy management work. Also, you will learn the classify and classification of the major categories of building energy management methods and the control paragraphs. Also, at the last, you will be able to identify and describe the representative rule-based energy management strategies for the like HVAC system, energy storage system, and the electrical appliance. So first of all, what is the energy building energy management? So we know that there are about 80% or to 85% of the total energy consumption during the building's life cycle occurs in the use or occupation phase. That refers to the use maintenance phase of the building life cycle. So you have learned some passive method that's or system that related to the building energy efficiency during the design and construction. Like, for example, you know that the shape or orientation and the building envelope and also the shading and some passive system, including and also the glassing, will influence the energy efficient of the building. But you may find that most of these factors are related to the design process, not the management process. It's before the operation of the building, but during the operation of the building, you need to like do some operation to to manage these resources in the building to make it more efficient. Here we have like some monitoring system to measures the energy consumption in the buildings, also the occupant or behavior in the buildings, and some other factors. Also, you will have the energy system inside of the building, like electrical system, the lighting, the HVAC, or other things. These systems are built during the design and construction process. And the things you can do is to operate during the use operation process, or you can reconstruct it. And also we have some very important one called the control strategy, that how to actually manage these systems inside of the building, the strategy. Also, there are, you need to satisfy the user's need of the building, like the thermal comfort or other things. So all these things well related to a very important concept called the building energy management. Okay, this is the process. The energy management in the building life cycle. Here is a very important fact about the building energy consumption in Hong Kong, that over 90% of the electricity consumption is from building in Hong Kong. Just the electricity, okay, because we have some other energy consumption like the fuel and the coal products. But that part is mostly related to the transportation system. Basically, about consumed by the cars. But for the electricity, over 90% of the consumption is from the building in Hong Kong. And you may see that uh, about like 44 are come from the commercial building, and 24% are come from the residential, and like 4% are come from the industrial. So that's the difference. Majorly the commercial. So we have different systems in the buildings. So for example, here in the, you can see from the picture, like the solar PV system, which is very popular now. So people try to have the uh, building integrated PV now in the in the buildings, both the commercial and the residential building. Also, we have the solar thermal system, which normally combined with the solar PV system. So the difference is that the solar PV system will change the uh, solar energy into the electricity, but the solar thermal system will change the solar energy into the heat for the building. Also, there are some other gener energy system from the generation side, including the like wind turbine. So this is not very common in the city, but it's sometimes, I may say sometimes happens in the uh, real side, not the urban. Also, there are some other important system. The most one is the HVAC, the energy efficient heating and cooling system here. Uh, and the lighting system also very important. And the energy star appliance. So basically, these three systems consume the majority energy in the building. Besides this system, we have some others like the water recycling and the water heating and mm, like rainwater collection, some other things. This system do also consume the energy, but the percentage is very limited. So after you know about many different systems, so what's the exactly building side resources that the energy building energy management can actually control? So the building energy building side energy resources, including the physical devices in the buildings that can either generate or consume energy. So and also some people may think that we only need to consider the energy consumption inside of a building. So this idea is not right. We should also consider the energy generation from the building too. Okay, that's very important. So from the generation side, we have the wind turbine, PV solar panels, and the solar thermal collectors, and a very important thing for the like for the specific building types, like the hospital or data center, is the fossil fuel generators. They have the small generator for the building when the electricity from the grid is cut it. Okay, when they lose the ability to get electricity from the grid, the power grid, they do need the generator to provide the necessary electricity to support the electrical appliance inside of the building, like again, hospital or data center and some other very important buildings in the city. Okay. And also another thing is the energy storage system, which is very popular now. We have like the battery energy storage systems for the home side, like the Tesla electricity bank, and some other things. Another potential energy storage system for the buildings is electrical vehicles, the EVs. So this is very important for the urban, because you may see that the electric vehicle number increase dramatically from like 2018 here up to 2024. So although the Hong Kong doesn't have a very popular of the e electric vehicles, but the number is increased dramatically because the government have many plans to replace the EVs to replace the traditional fuel-based cars to the electric vehicles. They have some plan to supply it. But the very important thing is that the EV do need some fundamental facility like the charging station to support the EV, which is not common now in Hong Kong. Also, there are some other traditional systems that consume the energy in the buildings, like the very important one, the HVAC system, and also the electric appliance, and so on, some other things. Here is a very typical load information about the what exactly is the energy electricity consumption by the end use in Hong Kong. The majority is the air conditioning, which counts about like 30% of the electricity in Hong Kong, and also the lighting is about 10, and the refrigeration is about 5%, and also the industrial processing equipment. Another thing is the cooking, since a lot of people now try to use the electric appliance to cook at home or other place. So the electricity consumption of the cooking increase like from 6% to 9% from 2012 to 2022. Also, another important one, energy consumption is the office equipment. But this part of electricity decreased because many companies try to use some energy efficient electric appliance now. So also there are some other things like vertical transport and others. So this is the electricity consumption by end use in the building. So after we know that there are many different systems that consume the energy, so I will give a more detailed introduction about all these systems. The first one is the HVAC, the heating, ventilation, and air conditioning system that maintains and controls the temperature and humidity levels to provide the adequate indoor environment for human activities or some processing goods. So for the HVAC, so there are different types for the buildings, the centralized system and the decentralized system. And also for the ventilating, there are constant air volume system and the variable air volume, so which can provide the constant air or variable. So that's the difference. So I will not introduce this system very detailed because you will be told in another course. Okay, but I can show you a very simple video about the district cooling system in Hong Kong. I don't know. Yeah.
Air conditioning system. Air conditioning can be considered an essential facility for buildings in Hong Kong, in particular throughout the hot and humid summer months, which the outdoor temperature reaches well above 30 degrees Celsius. There are generally two types of air conditioning systems which are commonly adopted, namely the unitary air conditioner and the centralized air conditioning systems. Unitary air conditioners, which include window type and split type air conditioning units, are usually adopted for individual domestic flats. They consist of an indoor section for supplying cool air to the conditioned space and an outdoor section for rejecting the heat to outside. For the high-rise commercial buildings,
So that's majorly for the residential buildings, so that's different.
as office buildings, hotel and shopping malls, it is undesirable to cool the individual space with separate unitary air conditioning units. The centralized air conditioning systems are used to minimize the unsightly outdoor units mingling with the elaborately designed external walls to provide better air distribution and to achieve better energy performances. A conventional centralized air conditioning system comprises one or multiple chillers which are used for chilled water production. The chilled water produced is then distributed via pipework in the building to the cooling coils of the air handling equipment at individual spaces, in which air is driven by fan to blow across the cooling coil, and then the cooled air is delivered into the space to achieve the overall air conditioning for the building. What is district cooling system? District cooling system is an even larger scale centralized air conditioning system. It consolidates the chillers required in each individual building into a central plant serving the centralized air conditioning system of the buildings in the district. The chilled water produced at the central plant will be distributed to consumer buildings through a closed-loop network of underground pipes. The cooling energy required by each consumer building will be transferred via the heat exchanger installed at the building plant room connected to the distributing chilled water pipes of DCS. Why we have district cooling system? Building owners have benefited from district cooling system as they are no longer required to install their own chillers and associated equipment from their buildings, resulting in not only a reduction in upfront capital costs from equipment installation, but it also significantly reduces environmental problems caused by noise, vibration, and thermal plume generated from the chillers and associated equipment in the building. The freed up space also allows more flexible building designs and improvement in space utilization. DCS is an energy-efficient air conditioning system as it consumes 35% and 20% less electricity as compared with traditional air-cooled air conditioning systems and individual water-cooled air conditioning systems using cooling towers, respectively. The reduced energy consumption of using district cooling system helps to reduce fossil fuel consumption for power generation. Consequently, greenhouse gas emissions such as carbon dioxide, which is the leading cause of global warming, can also be reduced. District cooling system in Hong Kong. To further promote energy efficiency and conservation, the Hong Kong SAR government has implemented a district cooling system at the sustainable and environmentally friendly design Kai Tak development to supply chilled water to non-residential buildings for centralized air conditioning. It is the first project of its kind to be implemented in Hong Kong. It is planned that the DCS will serve about 1.7 million square meters of non-domestic air-conditioned floor area with a total cooling capacity of about 284 megawatts of refrigeration, which is equivalent to the cooling demand of about 40 numbers of 30-story commercial buildings. To match with the development schedule of Kai Tak development, DCS is being implemented in phases. Construction of the first phase commenced in February 2011. DCS operation commenced in February 2013. Currently, it is supplying chilled water to the Kai Tak Cruise Terminal and Chinglong Shopping Centre. Upon full development, about 39 kilometers of underground chilled water pipes will have been laid. The annual savings in electricity consumption will be up to 85 million kilowatt-hour, with a corresponding reduction of 59,500 tons of carbon dioxide emission per annum, which is approximately equal to planting 2.3 million trees in an area of the size of 120 Hong Kong Victoria Park for carbon dioxide reduction. The construction works at Kai Tak development are still ongoing. In the coming years, commercial buildings, hotels, hospitals, schools, and sports complexes will be completed in succession, and ultimately, all these buildings will be provided with chilled water from the DCS.
So this video is made very early, but here you may think that why do we need a centralized cooling system? So it's a little different. Just like why do we use the centralized heating system in the North China that has centralized heating system, right? They fill the heated water to provide the heat to the residential buildings. So a very important thing is that the energy efficiency to generate such cooling or heating energy is more efficient than the distributed energy system. But another important thing is that if you translate or transmit this energy, they will also cause the energy loss, right? If we want to like transmit this chilling water from one place to another place, it will cause the energy loss too. Okay, this is the balance between when do we choose to use the centralized system or the distributed system. You need to consider both sides from the generation efficiency and the transmission efficiency. Okay, that's two important things. But here it's all about more about the environment factors, like we can like build more trees or some have more better environment for the urban area if we have the centralized system. Mhm. Okay, besides the cooling or heating system, we still have the ventilation system. So it provides the fresh air to the buildings. Also, it's a very important thing to control the level of dust, gases, fumes, or vapors in some industrial applications. For example, in the parking garage, we can use the ventilation system to control the carbon oxidize exposure in the parking area. Because we have a car, we have the uh, some gas that we don't want to expose it to the occupant. But a very important thing is that the ventilation system is largely influenced by the air condition outside of the building. So if the building is near to like the roads or some other have heavy pollution, so you may need to consider that too. But this is majorly related to the occupant's feeling. Okay, not it's also related to the energy efficiency, because sometimes if the outside air is like cool or heat, we can use this type of air to heating or cooling the inside air of the building. So like here, it can decrease the heating or cooling loads of the building. But in some climates or period of the year or the day, so providing more air ventilation can be beneficial or may actually reduce the cooling and heating loads by using the outside air cycles. Another important energy consumption in the building is the lighting system. So normally there are several factors that we should consider to determine the proper level of the light in a particular space, because it's not in the whole building, but you need to decide the control of the lighting in a specific area, including the age of the occupants, also the speed and the accuracy requirements, and also the background contrast. The age of the occupants is majorly dependent on the function of the building, and the speed and accuracy is related to the usage of the area. For example, the lighting system inside of a library should be different from let me see, office or in a rest room and other things. So there are different types of light. Here I gave two examples, the LED and others, because we majorly use LED now. Uh, and also, we have very simple rules for the lighting controls like occupancy sensors. If the sensors sense occupant inside of the room, it's light, and if we don't have any uh, occupant in the room, so it will turn off. This is very simple one. And we also have the lighting dimming system to adjust the power of the light, like with different levels. Here is a table of recommended lighting levels of different applications in the selected countries. So very simple one with the lux. So you do know what's the lux, right? So it's a unit of the lighting, how much light you need to get. Also, for the energy management, there is another things that you people normally ignore. It's electrical appliance. For the office equipment, we usually have the Energy Star labeled products that you can see from the equipment. Uh, this type of products can save as much as like 70% of the total electricity used of that specific devices, depending on the type and the usage pattern of the office equipment. Normally, it can be changed to the low power sleep model and the work model. So it changed to the sleep model when the idle for specific when it is idle for a specific period of time. For example, copiers can go into the low power model of only like 15 to like 45 watts after 30 to 90 minutes of activities. Here, I can give you like half a minute to think. What else equipment are there in the office that can also have such capability? Okay, I think the example is shown in the picture. So it's heating water. So you may see that with a very simple rule that the devices will keep the water into like less than 100 degree, like 98 or 97, when it is idled, when no people use it, and it can heat the water back to 99 to 80, 99 to 100 centigrade in 2 or 3 minutes. Only this, if we just apply this very simple rule for the devices, can save like more than 10% of the energy consumption of such devices. Just a very, very simple rule. So this is for the office equipment, which since it is used in a pattern that people will free it for much longer time in the daytime. So and also the night. So we can use such simple rule for the devices. Also, we have the residential appliance. So there is different from the office equipment. There is a very wide range of label used in the different countries to promote the energy efficient for the appliance, like for the refrigerators, freezers, clothes washers, dishwashers, dryers, water heaters, and other things. So many. So we normally use the energy label to know the energy efficiency of the electrical appliance in the residential home. Okay. So here is an example about the, I think it's the room air conditioner. So this is in grade 1, the highest, and the annual energy consumption is about 620 kilowatt hour for cooling, and some other things related to the label. So besides the energy consumption, we do have some other things that can be integrated into the building. That's the generation, the renewable energy generation for the buildings. There are different types of energy, renewable energies that we can integrate into the buildings, including the solar. We have those PV, and we have the wind turbine, also the hydro, the tidal, the geothermal, biomass, hydrogen, and also the nuclear. Normally, we consider all these resources as renewable energy resources, but for the building, we normally use the solar, wind, and the biomass. These 3 types of renewable energy for the building. Solar, we have the PV, and wind, we have the wind turbine. Biomass, we have the thermal generation. For the energy storage system in the building, we have like the thermal storage and the battery storage. That's different types. For the thermal storage in the commercial building, there are many buildings that use the ice storage. It's cooling the water and to change it into ice and storage in the basement. And when they try to use it, they will use the cooling energy from the ice. There are also other like the heat water storage, but these 2 types are majorly used to support the HVAC system only. And it's also related to the place of the building, because you don't want to use the heat waters storage in the building with in the like very north place. Also, here is a picture of the ice tank. So they store the ice inside of the building, and when they try to get the cooling air, they will try to extract this air or cooling water and use such energy in the HVAC. Another very popular energy storage system now is the battery storage. So it is normally installed in the building with the renewable energy, because when the renewable energy generation is very high, when this energy is more than the energy consumption inside of the building, you will lose such energy, right? Because it's free. And also you cannot inject this energy back to the grid. So we need something to storage such energy and use it later. So this is why we have the battery storage now. It can be responded in a very fast and accuracy pattern. This is very important because when the renewable energy also changes in a very fast speed. Also, you do not need to have the energy conversion for the battery storage system. because it provides the electricity, not other type of energy. The electricity can be directly used in the building. So that's different from the thermal storage. I think the previous system are very common for you, and I can give a more detailed introduction about the electric vehicles. So there are different types of electric vehicles nowadays. The most common one is the battery energy electric vehicles, the BEV, and we also have the hybrid vehicles. Two types of hybrid vehicles: the plug-in hybrid vehicles and the hybrid electric vehicles. The plug-in means it can be charged through directly to the battery side of the vehicles. The hybrid electric vehicles is a little different, that the battery inside of the electric vehicle cannot be charged directly from the grid. It is charged from the fuel energy. Okay, it's changed the fuel energy to the electricity and the storage it into the electric vehicle. So that's different. We also have another type called the fuel cell electric vehicles, which use the fuel cell instead of the traditional battery. So you do know what is a fuel cell, right? So it's like it is not the electric change inside of the cell. It's the oxygen combined, for example, the oxygen combined with the hydrogen to generate the electricity inside of cell. It cannot be charged with the electricity. It can be used only once. And when the energy inside of the cell is consumed, then you cannot reuse it. So that's the difference. It's a fuel cell. If you don't understand, you can check it. Okay. We also have another type called extended range. So maybe it's very common in China called 增程. Okay. Extended range, the 增程式 electric vehicle. Also, besides the electric vehicle, you need to know that there are different types of charging mode for the EVs. Normally, there are 4 types, but commonly used only for 2. The first one is the slow charge. The maximum intensity is like 60 amp, and you can use the standard single phase or 3-phase power outlet. So this is most used in our homes. We also have the semi-fast charging with the maximum intensity of 32 amp. And it's the same. It has a single phase or 3-phase power outlet. This type of charging can be used at home or in public areas. Another very popular now is the fast charging. So the intensity is between 32 to 240 amp. But this type of devices require to use an EV supply equipment to support the fast charge. Okay, you need some extra devices besides compared to the slow charging, and also the protocol for this type of charging is different. They do have try to like research to develop the different charging model that have a higher efficiency called the ultra fast charging. So it can direct connect the EV to the supply network, and also the intensity is can up to 400 amp and a maximum wattage of 1000 watt. Also, it do require an external charger. So this is a different of types of and charging mode of the electric vehicle. So besides the devices or system inside of the building that can reflect, influence the energy efficiency of the building. So there are some other factors like a very important thing is the electrical distribution system inside of the building. So it provides the electrical energy to the equipment inside of a building and try to keep this system safety, all the equipment safety, reliable, and economical. There are two factors that inside of the distribution system that may influence the energy efficiency. The first one is the transformer. So it will normally cause like 1 to 2% of energy loss. So the transformer is the devices that change the voltage level inside of the building. Because normally we get the high voltage level from the grid and we need to change it in the low voltage level that's suitable for the devices, appliance inside of the building. So here is just a very simple sample of the transformer. So how the voltage and is changed in the transformer. Another thing is the electrical wire. Because when we try to transmit the electricity, so the wire will generate heat, right? It will generate the heat by the flow of the current through the resistance of the conductor. So this is something that you may learn in the high school. So the resistance will generate the heat, and when we have the current go through it, and the P is equal to R times I square, and normally R is equal to the length of the Y. Okay, because if we have the longer Y, you will cause higher energy loss. So this is why we need to increase the voltage level if we want to transmit the electricity from one place to another, because the R is fixed. But if we increase the voltage, the I will decrease. So this P then can be decreased. So here is a very simple example of the energy loss cost calculation of the electricity line. So for example, if we want to calculate the annual energy loss cost of the electrical wire on a 400 meters branch that feed a load of 16 amp, and we assume that the resistance of the wire is like 0.36 ohm per 100 meters. And the load is used like 10 hours per day and 250 days per year. And the cost of the electricity is 0.1 kilowatt hour. So we can use the heat loss in watts to calculate the power loss. So the P is equal to R times I square. So the energy loss will be 0.36 times 400 over 100, because we have the 400 meters, but the resistance is 0.36 per 100 meters. So you need to divide 100 meter and times the amperes square. So it's like 368.64 watt. And the energy loss cost would be the watt times 10 hours per day and times 250 days per year. And we need to change the 1 kilowatt over 1,000 watts and times the electricity price. So it would be like $92.16 per year. So this is how we estimate the energy loss cost by the electrical wine. Also, there are some other factors. Very important thing is the climate and the weather of the building's location. The climate zone include have made 5 major climates, including the severe cold, hot summer, cold winter, mild hot summer, and the warm winter. So that's the deviation of the climate zones. So this is very simple classification method, and it majorly concerned with the conduction heat gain or loss and the corresponding thermal insulation issues. Also, there are some other things that would also influence the energy efficiency of the building, like the climate change, because the cooling and the heating demand of each city is responded differently to the climate change. In general, the former was predicted to experience an increase. The cooling demand is normally predicted to experience an increase in worldwide, but especially in the warm climates, while the later decrease, especially in cold climates, and remain still in the warm climates. So that's the difference about the cooling and the heating demand in different rooms. Another thing is influence the energy efficiency is the extreme weather, which is happen more frequently and stronger nowadays. For example, the hurricanes, the heat waves, and the cold snaps. But how exactly it influences the weather? So it includes the daily maximum, the daily minimum, hourly maximum, hourly minimum for an initial set of variables of the dry bubble temperature and so on. And also, a very important factor that influences the energy efficiency would be the operation of the system. Here is a very simple scheme related to the heat resources of the office room in the table. You may see that it's set a rule that the lighting system is from Monday to Friday, the work days is from 0 in the night is about only 12% and 100% during the daytime in the workday, and also again back to 12% in the night, and also about 12% in the Saturday or Sunday in the weekend. The equipment is similar, so it's about 80% in the daytime in the workday. The 100% in the daytime in the workday, and 18% in the night or the weekend. You may see that the energy consumption only happens when there are people inside of the building. And if there are no occupants inside of the building, so there are no energy consumption of it. The table gives the example of the lighting. So, the heating resources, and the picture gives the example of the air charge rate. So the occupancy is a very important factor that influences the energy management inside of the building. So although we talk a lot about the energy efficiency inside of the building, another important thing that we need to consider is the electricity rate, because the energy is just the energy, right? You only need to pay the money to the company when it is important. So different types of electricity rates is considered for the different types of participants, not the building. For example, we have the block pricing rates. This type of electricity rates is depend on the rate of the electricity consumption using at the inverted or descending blocks. So this is normally for the residential buildings in Hong Kong. Well, let me see if so this is a very simple example of this type of electricity. So for example, it is calculated in blocks. For example, for the first 150 units, it's only like 77 cents per unit. And for the next 100 units, it would be increased to 91.8 cents per unit. And if it increased the next 200 units, there would be 105.7 cents per unit. So when the units increase, the electricity price also increase. Okay, for example, so this is the block pricing rates. Another type of rates is called the time of use rate. So this type of rates is commonly can be commonly seen in the mainland China. The time of use rates is the time differentiate rate, where the cost of the electricity varies during the specific time of the day or of the year. The time of the use rate sets normally the on-peak and the off-peak periods with different energy or demand charge. So this is normally happens. This is normally related to the load changes and the renewable generation changes inside of the grid. For example, on the on-peak periods normally occurs during the daytime hours, which have a higher energy cost and the demand than the off-peak periods. People use more electricity at that time. So this means that the power grid do have more pressure to generate higher power inside of the grid. So this means the cost of the electricity will also increase. The power grid want to put this pressure to the user side. So it's a time of use rate. Also, there are another type of rates called the real-time pricing. So this type rates was first offered by the Pacific Gas and Electric in 1985. So like the time of use rates, it's time differentiate rates. But this type of rates, for this type of rates, the cost of electricity varies on an hourly basis. And usually the units inform their consumers the hourly electricity price only a few hours before they take effect. That's a different to the time of use rates. For the time of use rates, you will be told when you sign the contract. Okay, like from time to from like 2 to 5, it will be like 1 yuan per kilowatt hour, and for night from it will be point like 5. So you will be told the exactly price and the period of the in the time of use rates. But for the real-time pricing rates, the price is calculated in real time. You don't know what exactly the price is when you try to use it. It's only be told only a few hours before they take effect. It's more dynamic than the time of use rates. We also have different type of rates, like the seasonal pricing rates and the specialty rates is based on the seasonal changes and the specific design of the electricity rates. So here is an example of the electricity cost calculation for the block. So the question is, what's the average electricity cost for 200 and sorry, let me see, 200, 600, and 1,000 and 100 units. So if it's 200, though, the cost would be the first 150 times the corresponding rates, and since it goes to the next block with only 50 units, and it would be 50 units times the corresponding rates. And for the 600 units, so it would be go to the block 150, 150, 200, and 100 in the 1, 2, 3, 4 in the fourth block. Also for the 1,000 and 100, you will it will go to like here in this block. So it's the sum of these all units times corresponding rates together. Okay, this is very simple, so I will not go through it in details. So you have learned so many factors that may influence the building energy management, also the energy efficient buildings in Hong Kong. So let me ask you a question. So what are the most important 3 factors for building energy management in Hong Kong, and why? I will give you like, let me see. Okay, I can give you like 5 minutes to have the discussion, and you may discuss with your classmates or like anything. Okay. No, do not like discussion. So okay, I'll give you like 2 minutes to think. Okay, this is very important. So the questions in the lecture are very important. Okay, you may think and prepare. Okay, I think all of you don't like to have the discussion, so I will just tell you my answer about this question. So, maybe first of all, I think the HVAC is the most important one because it has the largest energy consumption inside of the buildings in the Hong Kong, and the second one is EV because it has a very large potential to affect the energy consumption in Hong Kong, and also because the Hong Kong is promote the electric vehicle in Hong Kong, so it will I think it will consume a very large proportion of energy consumption in the buildings because the electric vehicle need to charge, right? So it will have a large influence of the electricity consumption of the buildings. And the third one, I think it would be the weather. Uh, if we want to be more specific, I think it would be the extreme weather. Because as the you know that as the temperature increase, the Hong Kong is facing more and more hurricanes and heavy raindrops in the summer, and all these factors will influence the not only the energy management but also the energy resilience of the buildings in Hong Kong. So that would be a very important factor that would influence the energy management of the building, not only the energy consumption but also the energy resilience of the buildings in Hong Kong. So that's my answer about this question. Okay. I think we can go through this video and then have a then have a break.
Bear markets and bull markets. So, what do you find that
with energy bills increasing and ESG high on the agenda, we at
So what do we exactly use to actually manage the energy in the building? So we need an energy management system. So that's what I will talk about in the later half of this course. So we'll now have 10 minutes break and we'll start at 8. Okay? Okay, okay, it's 8 o'clock, so I think we can start the second half of this course. Okay, so first of all, I will give you a very brief introduction about the development of the BMS, the Building Energy Management System. So the key function of the building energy system is to monitor and control the energy-related resources and the devices in the building system. So it is first developed in 1970s, but at that time it was very costly and were most used for large installations, which had the ability to perform some simple calculation and perform the control decisions. This is majorly because they don't have the computer at that time, the high performance computer, and also the devices for the automatic devices for the buildings is also very limited. And in 1980s, the microcomputers have been used to support the BMS. At that time, it was firstly designed for controlling the major energy components in the building. So that refers to the HVAC system, lighting system, and the lifts. But very limited. And in 2080s, with the wider development of the IoT technology and in the buildings, it enabled the controllability of the variety of the plug-in electrical appliance and equipment that were not typical management with traditional BMS. Also the development of the internet and also the computers. Here is a very simple example of the building management system. So in the building, we have different systems in the lower level. For example, the HVAC. For the HVAC system, we have the pump, AHU, chiller, or some other things. And for the critical units, we have the compressed air or other boilers, and some other things. And also we have the lighting system, process equipment, and also the EMS. So you may find that in the building, the system is divided into different the subsystem. It is divided into different subsystems, and the EMS is developed to control it in a higher level. But this would change, it would be a little different for the home energy management system. So everything are collected directly to the BMS. When in the home, we have the energy from the grid and the renewable energy that, and we have the occupant and the battery energy storage system and some other, here the scheduled appliance means that it can be controlled. The non-schedulable appliance means it cannot be controlled. So all of these system, let me say devices are directly connected to the BMS for the home energy management system. So for the building one, it has its own system, and all the system are connected to the BMS. Okay, that's the difference. So what's the benefit of the BMS? So there are multiple benefits to the stakeholders, so including the building occupants, because it can make the occupants to have higher comfort, satisfaction to the building, and also the building owner and the managers, because if we have higher energy efficient for the building, it can increase the property of the building. And also the smart grid, because if we can adjust the load in the building side, it means that we can support the operation of the power grid. So here is a list of the benefits. First of all, it can minimize the operational energy cost. So here I want to emphasize the cost, not the energy, because we normally try to consider the operation cost of the building. Also, it can improve the comfort and the productivities of the building occupants. So this is why we do also need the BMS. Also, it can have the staff saving and reduced maintenance costs because it normally have a higher degree of the automation level. And also it can supporting the sustainable energy practice because if we want to use more renewable energy, which are normally fluctuate and have high uncertainty, so we do also need the building energy management to support the renewable energy. So the first important, I may say, the basic function of the BMS is to monitor the building's power generation and consumption. This is the most important, I may say, basic function of the system, and with such information, we can understand the real-time energy performance of the building. So although we talk about the energy consumption, energy efficiency of the building, we can not know what exactly how much energy efficient we can get if we don't have such a monitoring system. Okay, that's a very important one. Also, we need to use it to support the energy management because we want to know the state of the building. Now, then we can do the management. Also, we can use the data from the monitoring system to forecast the future power generation and consumption to support our management. And also we can monitor the health condition of the resources because the devices can also be old, and we don't want it to suddenly break down. We want to know the healthy state of the resources, especially the devices. Also, we can use it to analyze the occupants' behaviors inside of the building, when the people arrive the building, when they leave, and how many people normally arrive and how many people normally leave. The right bottom picture is an example of the monitoring system in the building. It has a network connected to the switch, and the system is classified for different according to different devices. For example, we have the lighting and socket, and the air conditioning, power, and some others, and also the water, and also other gas monitoring system. But how do we actually get the data of the electricity? We need to use the meter to measure the electric power flow. So the watt-hour meter is a typical devices that measures and records over time the electric power flowing through a circuit. So this is a very important thing that we get the data in the building. The development of the watt-hour meters is from the electromechanical induction meters. So normally this is the oldest one, which can only measure the electricity energy consumption. But in the electronic energy meters, it has more parameters, and it can display the energy consumption. And nowadays we have the smart energy meters. A very important thing is that it has a two-side communication. It can send information from the user side to the power grid, and it can also get the information from the power grid from the higher side. So this is a two-side communication. So the basic physical principle for the watt-hour meter is it has a motor and a counter, where the motor's speed is proportional to the current flow, and the counter checks the energy usage based on the motor's revolutions. Here is a video about the smart meters. So
smart meters measure how much gas and electricity you use. They're the newer, smarter upgrade currently replacing regular gas and electricity meters up and down the country. And the government has asked energy companies to make every effort to offer them in all homes by 2020. Smart meters measure your energy use 24/7 and send this data wirelessly straight to your supplier. This means you should no longer need to take a manual reading and can say goodbye to estimated bills. When you have a smart meter installed, you get one for gas, another for electricity, and a separate display called an in-home display, or IHD. These devices connect up and the smart meter sends across your usage data to the IHD, so you can see how much energy you are using in real time, as well as how much it costs. For example, if you boil a kettle, you'll instantly see your usage rocket up. You won't be charged for having a smart meter installed, but the cost of rolling them out to all homes will be added to everyone's bill. Plus, it could save you more money by encouraging you to use energy more efficiently. Millions of smart meters have already been installed in Great Britain, and problems have been cropping up. A common issue is that some first-generation meters have lost their smart functionality when you switch supplier. However, wireless updates should bring these back to life, and if not, your energy company is required to install a new one by the end of 2020. Despite the frustrations and teething problems, we think smart meters are an important way forward for a more efficient joined-up energy system and will give you access to new products and services in the future. However, if you don't want one, you can just refuse. For your rights and more info,
So a very important function for the smart meter is that it can send the information directly to the supplier. So we do not need the manual, the people to go through your home to collect the information. So that's a very important factor for the smart meter.
smart meters.
We also have different sensors, and for example, the occupancy. So an occupancy sensor is an indoor device used to detect the presence of the person. So there are different types of the sensors, like the passive infrared sensor. This is commonly used in the office and some public buildings. So it measures the infrared light radiation from the object. We also have the environmental sensors, which measures the change in the environment caused by the presence of the human. We also have the key card light slot and the smart meters and the door operate switch. This is a door operate switch. It's like we open or close a door, it will sense such operation. And we also have some other more advanced technology. For example, the image processing. It can get the screen video flow and find the corresponding people who go through the picture. Another one is the indoor air velocity. So this is not commonly used in the buildings, majorly because most of them are very expensive. So it's high cost. So we don't usually put a device in the building to measure the air velocity, but it can be used in the HVAC system. So it's commonly in the HVAC. There are also some others, for example, the lux meter, gas meter, thermal meter, and the plug-in electricity meter. So later two is commonly and very cheap nowadays. And if you want to use this in your home, so it's for the thermometer, it's like about around 200 Hong Kong dollar. And but for the plug-in electricity meters, it's a little complex because it's hard to communicate with the energy management system in the building through the plug-in electricity meters. The cost of such meter is much higher than the energy efficiency that it brought. So that's why we seldom see it in the home or other place. It can normally used for just a short period of times measurement. After we have the monitoring, so a system, we can get the data, energy consumption of the building. So the second thing is that we need to forecast the both load and the energy generation of the building. The first one is the load forecasting. We normally need to forecast the building's power consumption over a period of time, so we can schedule the controllable energy resources. This is a very important thing because sometimes, for example, for the HVAC, we can use preheating or pre-cooling strategy to preheat, or we say pre-cooling the building in the summer before the occupancy arrive the building to ensure the comfort, the user satisfaction. Okay, that's why we need to do some forecasting of the energy consumption. Also, the electricity price will also influence such load. So sometimes we can change the load to the low electricity price period of time. Another thing is for the building with renewable energy resources, we also need to forecast the renewable energy power output. So the power output of the building's on-site renewable energy resources, it can ranges from like minutes to the weeks. For example, minutes means that we predict such energy generation in like 5 minutes above it actually happens. So we can like turn on some 5 minutes appliance before it actually before the energy generation of the renewable power increase or decrease. So the operation plan for the energy resources is dependent on the forecasting of the renewable energy. So with the accurate forecasting, we can utilize such renewable energy resources better. Also, it can, since we can, if we can utilize it better, it has different directions. One direction is to reduce the amount of energy import from the grid. Because we use the on-site renewable energy more, we can reduce the energy, the electricity from the grid. Okay, so if we have a fixed amount of load. Sometimes we use the numerical weather prediction model to predict the wind speed and the solar irradiation of the weather to change it to the renewable energy power generation. Because the for example, the wind turbine is the generation of the wind turbine is closely related to the wind speed of the environment, and the generation of the PV is closely related to the solar irradiation. So here is a very simple example about the machine learning based wind power forecasting. Before introduce such method, I just have a very simple question for you. I heard that some of you have is come from the major AI, the AI, right? A, B, C, D. Okay, so it's more related to the AI or something because I'm told from the Professor Lee that I need to talk about more about AI in this course. No? Okay. So are you interested in AI more? Because sometimes I find that students have a very good background about the building and they want to know more about how to apply artificial intelligence in the building. Yes. Okay, good. I will try to talk more about the AI, how to apply AI in the building, especially energy management. Okay, so if we want to like use machine learning to do the wind power forecasting, the first step is to do the data pre-processing to prepare the data that could be used to train the machine learning model. Okay, this is the first step. So the in this example, the historical data has 6 features, including the wind speed, wind power. They are used as the input of the data processing part as an incomplete low frequency data. And those missing value, duplicated value, and outer layers. So because the incomplete low frequency data means that, for example, we have the like 1 hour data for the wind power. So we have sometimes we cannot get the full 1 minute, the 10 points of the 10 minutes wind power forecasting. Sometimes we miss 1 point or several points of data. So that means the missing value. And the duplicated values means that sometimes we we get the data from devices for multiple times, and it has some trouble to get the new data from the devices. So it duplicates the values again from the devices. And the outer layer is we have some measure, other types of measure problems that it measures a very high or low generation point. So that's the outer layer. So first, we need to make sure that all these data are processed. For the missing value, we can use like the previous one, the value to fill it. And for the duplicate, we can use the value above and after the point to get a mean of these two above and after the point to get the change to the duplicate value. And for the outliers, we can reduce the range or other things. We have some processing method to pre-processing the data. Also, we can we need to normalize it to obtain the low frequency data. After we prepared such data to form a data set, okay, we can use it to train the data. So this is a machine learning part. The data are used as the input of the SAPR. So this is in a model, and the complete high frequency data are planned to enhancing the historical data through the SPR part. So it has the input and the output of the machine learning of the model. So we use this data set to train, to adjust the parameters inside of the model. Okay, that's we have many different machine learning methods. But I think the most important thing is that after we have the data set, we can use it to train the parameters of the neural network. Okay. After it is trained, we can use it to do the prediction. That's the whole process. So based on the some new data, we can input it into the trained machine learning models and to get the new forecasting result and use it as the new forecasting. So here is the result of the previous introduced method. The short-term forecasting are normally less than 10%. So here are different neural network structure, like conventional neural network, long short-term memory, and generative adversarial network. Okay, that's how we use machine learning to do the forecasting task. Another thing for the energy management system, of course, the most important one is energy management. We need to schedule the building site energy resources, including both generation and consumption resources. So to develop the operational plan for the building site energy resources. So there are different type of strategy ranging from the simple rules to the algorithm design. The objective of the energy management is including to minimize the building's energy cost, satisfy the occupants' comfort, manage the building's peak power consumption, and regulate the grid's operation, and also minimize the disturbance of the power outage. The peak power and the disturbance are related to the power grid because we don't want the load to fluctuate very much, and that will influence the safety operation of the power grid. So that's something that the power grid want to see, not the building. Okay. Here is a typical process for the energy management. So first of all, we need to do the day-ahead forecasting to predict the renewable energy generation day ahead, and then we do the day-ahead scheduling of the renewable energy resources, like how much electricity it should generate for the building, and also for the real-time operation, we need to know the exactly state of the building resources and do the actual operation. So normally we do have a plan first and then do the real-time operation. There are some other types of energy management that you may consider for the buildings. The first one is the energy sharing. So this happens when you try to management of a group of buildings in the normally in the community level, which enable the energy sharing among buildings and to accurately control appliance in multiple buildings, part of the same community. So the left one is the peer-to-peer energy trading example. So for example, for this building, it has a PV generation, and so it would be a prosumer. Prosumer means both producer and consumer. Okay, prosumer means it can both generate and consume energy. Producer and consumer with solar energy. But for this building, it's only a consumer. So which means that if the renewable energy generation is higher than the energy consumption of this building, it can sell the extra energy to the consumers in the community. Okay, this is P2P means that we do the energy trading from building to building, not included power grid. And right one is neighborhood energy management system, which is similar to the previous P2P energy trading. So this is just a concept, okay, energy sharing that you may consider when you do the energy management. Another one is called demand response. Demand response, it refers to the ability of charging the power consumption profile of energy consumer to match the demand of the power with the ability supply. So for the word response refers to that energy consumers can actively reshape their power consumption profile. Reshape means that, for example, if we do nothing, do not control anything about the building, it has a baseline. Okay, if we have no influence to the energy consumption of the building, it has a baseline. But this baseline may have a high peak here, but the power grid do not like this high peak because they need to arrange the power generation to follow the load shape. The response means if the power grid has such a requirement or request for the buildings for the demand side to lower the peak, so and the building takes action to respond to such a requirement, then there will be the demand response. For example, if the a very simple one is that, for example, if the power grid have a cursory high load peak in some period of time, and it want to cut down some load from the demand side, it can send information to the EV charging station, and the EV charging station can just simply stop the charging of the EV in the station, and the load will directly decrease. Okay, that's the meaning of response from the demand side. Okay, any question? Demand response. Okay, that's different for the traditional operation of the power grid, because the traditional one, we have the load, and the power grid usually make the generation side to follow the load. Okay, it's like we have like 1 megawatt hour in the generation side, in the load side, then we need to adjust the generation side to 100% match such 100 megawatt power consumption. But for the demand response, the power grid do not only ask the generation side to adjust their power generation, but also ask the load side to adjust their demand. So that's the demand response. It's related to the power grid, okay? There are different types of energy management strategies. So the simplest one is the rule-based method. So it operates the devices according to the settled rules. Here is a very simple example. For example, the energy resources is less than the load, so it's just adjust the load to demand. It set the demand to this such amount of number, and for the else condition, that's the renewable energy power is greater than the load, so it has a surplus of the energy renewable power, and it charge it into the battery. So that means the rules, just some rule. We set a point for some, we set some operation for a specific condition. If something happened, then we do something. So that's a rule-based method. For the mini project, you will need to design some rules for the energy management strategy inside of a home energy management system. And another main category of the energy management strategy is the optimization based. It needs to calculate the optimal strategy according to the model. It solves an optimization problem. For example, here it has a target function that minimizes the total cost of a period of time, and the cost includes the, I think this is the net load of the building, and this type of strategy will be told in lecture 6. And I think optimization methods is majorly the most common one, and also no, the rule-based is the most common one, and the optimization-based is I think the more likely to be applied now in energy management system. And we have some advanced one, but only depend in the research. The machine learning based method, it finds the optimal strategy with the learning method. And this type of method will be told in lecture 7. Okay, if you are interested, you can pay attention to lecture 7. Besides the energy management, the energy management BMS also support the human system interaction. It needs to communicate with different stakeholders, and the code works with them to manage the building's energy performance. For example, BMS can send different messages to people textually or visually to share the energy performance result or the operation condition of the building. This is not a video. This is just a example of the future in the human-machine interaction, because many people are trying to develop advanced interaction method for the human-machine interaction for the buildings. Not only like textual or visualize one, but it's just some concept. Okay, after we have learned so many things about the BMS, so here are some rules about different systems in the rule-based control method for the different systems in the building. First, for the HVAC, so we can consider it has 2 states. The first one is the operation state, and the second one is the standby state. So we can use S to represent the state of the HVAC. So for example, for S equals to 0, it means that the HVAC is standby. And for S equals to 1, the HVAC is at work. Since the power consumption of the standby model can normally very small, sometimes we just ignore it and set it as 0 for the power of HVAC. This is a very simple management rule of the HVAC. So when the temperature of the outside environment is higher than the room's temperature, the HVAC can operate in a cooling model. For example, here, sorry, it's not outside, it's the settled temperature. For it open the HVAC when the indoors temperature U in is greater than the settled temperature plus the width of the temperature that we think the human comfort can accept. For example, we normally say that we need to settle the HVAC temperature as 25.5, right? And the delta U could be like 1 degree or 2 degree, depending on the thermal comfort setting of the building. So which means that if the indoor temperature is greater than 25.5 plus 1, which means that 22.5, we open the HVAC. Otherwise, we close it. Okay, very simple rule for the management of the HVAC. Also, for the heating model, it means that if it's lower than the settled temperature, like the 25.5 minus 1, 24, which means 24.5. If it's lower than 24.5, we are open the heat model of the HVAC. And we can set the temperature of the HVAC. Also, we can set the temperature wise of the comfort band. Oh, here is a very simple example. It sets the temperature as 20 degree and the width of the band as 0.5 degree. So the comfort temperature band of the room would be 90.5 to 20.5. So this is what we need to design for the rule of the HVAC. Okay, that's the parameter we need to design for the rule of the HVAC. Here is an example of the cycling operation model for an HVAC. So here, since the temperature is out of the comfort temperature range at the first 0 time slot, the HVAC is turned on. And the temperature will inside would increase here and reach the 20 almost 20.5 degree. And we turn off the HVAC system and the temperature decrease and reach 18 degree. The lower and it will turn on the HVAC again and turn off it again after it reached the 20.5 and close it and turn on and turn off again and again. So that's a cycling operation model, a very simple rule. Here, the time slot, the minimum time slot is 1 minute. So you may set it open like 15 minutes and close for like 10 minutes and open like 8 minutes again and again. Okay. That's the cycling operation model with the simple rule. It can be more complex if we set multiple time slots with different settle rules, settle temperatures. For example, in this one, we can divide it into multiple time slot sets, where the different temperature are applied with U set 1 and U set 2, respectively. So which means that the comfort band for different time slot are different. Here is an example. So it's increased to reach the temperature about 20 degree in the morning. Since in the daytime, we also get energy from outside through the window or the wall. So we can set a lower temperature settle point in the daytime. And it has a cycling in the daytime. And after at night, we can set a high temperature. In the afternoon, we can set a higher temperature set point. Because for the lower set temperature, it has less energy consumption of the HVAC. So this is how we like save the energy through the different set temperatures. This is another method for the HVAC control. So it's called the preheating or cooling. So it's majorly do the things before an occupancy period or before the high electricity period. So for example, if we have the people arrive at the 60 minutes, so we open the HVAC before they arrive to reach the minimum requirement, the comfort requirement of the occupancy. So that's preheating or pre-cooling. This is also related to the electricity cost, because normally for the low load period, it has the low electricity price, which means that we can open it in the low electricity price period to do the preheating or cooling, and this can reduce the energy consumption in the high electricity price period. Okay, that's the logic. Is that clear? Okay. Okay, so that's preheating or cooling for the HVAC. It can be more complex if we consider the renewable energy, because it do have some very simple strategy that when the renewable energy power output is less than the settled power output in the load, so we open it because we don't want to lose the energy generation from the renewable energy, on-site renewable energy, okay? Because it's totally free, zero marginal cost. For example, if we have the power from our own building, and we don't have any other way to storage it, we want to use it immediately, right? Because if we don't use it, we will waste such energy generation from the renewable energy. So this means that if it has a generation, we will directly use it with no other consideration. Okay, just a very simple rule. And when the renewable energy output is larger than some set points, we can set the HVAC state to be in operation model. So very simple one. That's the introduction of the simple rule-based strategy of the HVAC. Here's the rule-based method of the energy storage, especially the battery energy storage system. Here are some fundamental use of the battery energy storage system in the building. The first one is the emergency power backup. This is commonly used in the data center. And the second one is adapted to time varying energy cost. So it means that we charge it in the low electricity period of time and discharge it during high electricity price period of time. Okay, which means that we can use the electricity from the low period of time. Okay, very simple idea. And it can also accommodate the building side renewable energy and increase the utilization of renewable energy. This is similar to the logic of utilizing the electricity price. If we have actual renewable energy, we charge it into the BESS and use the electricity from the BESS when there are not enough renewable energy. Very simple rules. Here are some properties of the BESS. So the first one is the charging and the discharging power capacity. This means that how much power we can charge or discharge in a specific period of time. Power capacity. And the second one is the energy capacity. This is the amount of energy that can be stored in the BESS. So for example, how many kilowatt hour can be storage in the battery, and also the charging and the discharging efficiency. So this is related to the energy loss during the charging and the discharging period, because we know even for the energy, normally for the energy storage, it will lose some power during the charging and the discharging operation. The state of charge and the depth of discharge indicates the percentage of the energy stored in the battery and the percentage of battery that has been discharged. So it's just an indicator that how many power we have in the battery. And another one, the last one is cycle life. It's the number of charging or discharging cycles that a battery can operate in its lifetime. So this is normally considered as the degradation cost. So for example, if we buy this battery with a certain amount of cost, we can divide it with the life cycle to represent for each time of charging or discharging, we need to spend how much money to do the operation besides the energy consumption. Here is an example of the charging and discharging power. So for example, a BSS with charging power capacity of 3 kilowatt and energy capacity of 15 kilowatt hour, and the charging and discharging efficiency are considered at 95% and 92%. So given charging power of 2.5 kilowatt, we can calculate the time required for the BSS to fully charged from an empty state, and the time required for the BSS to fully discharged from a fully state. So the here we can calculate the charging time with using the capacity, energy capacity, the whole one to over the charging efficiency times the speed. So it will be 15 over 2.5 times, since we have the energy law. So efficiency with 95%. So it would be like 6.32 hours. This is similar for the discharging power. But the difference is that here it's use the discharging power over the energy efficiency, because the energy loss should be divided for the discharging if we times it back to the left for the battery, right? This is from the grid to the battery. For example, if we have 1 kilowatt power, so which means that we need to use more than 1 kilowatt hour to discharging. Here is a simple rule-based strategy for emergency power backup for the buildings. So this is very simple. So the BESS discharge to meet power demand at the time slot when we don't have enough energy, and we save it in the other times. So here the dashed line is the BESS discharge power here. Here we have in the first time slot we have a higher power need for the buildings, but the energy from the grid is not enough, so we use the BESS power to support such a demand. This is similar for the rest of time. And here is a strategy for time varying energy cost. So the BESS can be used to absorb energy from the grid in low energy price and discharge in the high energy price slot. And here are 3 conditions. So for the low energy price slot, the charging power normally is smaller than value between the charging power that's fully charged and the BESS charging power capacity. Because we need to not only need to consider the load, but also the capacity of the BESS. So if it's fully charged, we cannot charge anything in the low energy price time slot. So this is similar for the high energy price slot. We can discharge to support the energy's power demand. But we also need to consider the energy left in the BESS. If it cannot support someone, we cannot discharge. So and for the rest of time, we can do nothing for the BSS. So here is the strategy for on-site renewable energy. So the BSS charging and discharging power can be considered based on the renewable energy's power output and the BSS operational condition, and also the building power demand. A very simple rule is that the renewable power is not smaller than the building's demand. The BSS is charged by the surplus energy power, and for this condition, we have actual renewable power. We don't want to waste such power. We charge it into the BSS. And if the renewable power is smaller than the building's power demand, the BSS need to discharge. It need to support the building's demand to fill the gap between the renewable energy power output and the demand. This is very simple rules. Also, we have the energy management of the electric appliance. So the appliance can, the flexible electric appliance can be divided into normally two types: the time shiftable appliance and the power adjustable appliance. So these two appliances are different. For the time shiftable appliance, the power consumption is normally fixed, but we can adjust the operation time with a certain time range. So, for example, the washing machine, the dishwashers, and the coffee machine, we can change it. It depending on the shiftable time is depending on the occupant's behavior. For example, for different people, they can adjust the time range in a different lengths. For example, I can if I can wash the dishes after like 1 or 2 hours after I finish the lunch, it means that the flexibility of the shiftable time would be 1 or 2 hours for me, and for some other people, it can be different. But the time shiftable one means that it can only shift the time, not the power. Here is a simple scheme for the time shiftable appliance. First of all, we can identify the devices, including the washing machine, dishwashers, and some other appliances which operate during peak hours. So the peak means that it has a higher electricity price. It uses the time of use rate. Here, it means that for this appliance, it has a high cost. And then we can shift the operation time according from peak hours to the here called shoulder hours, while the operation of the remaining appliance remain unchanged. So here it's low electricity price time from 8 p.m. and after. So here it's changed the this appliance to the after 8 p.m. So for this example, the overall energy cost for scenario 1 and 2 are for this one is 4.3.5, and for this one is 1.5 around. So even we just shift some energy consumption, some from the high electricity price period to the low electricity period, you can achieve a very good performance. But this is just depending on the electricity price of the environment. If it's fixed, then we don't have such capability to do so. And for the power adjustable appliance, the operation time is settled by the building occupant, so it cannot be adjusted. But it can, the power consumption can be adjusted with a certain range. For example, for the lighting system, with different level. You can adjust the consumption based on the level of light present in a particular building space. This is different to the like we turn it off totally. The strategy that we turn it off when there are no occupant in the specific area. We can slightly lower the energy consumption of the building system, but still match the occupants' satisfaction of that specific area. So that's the adjustable. And this is commonly applied to the lighting and the HVAC system. Okay. Before the conclusion of this today's course, I want to talk something about the mini project in next course, just after the Spring Festival. So in that course, we will use Python to develop the home energy management strategy. I will provide the basic code templates and data sets before the class. I think maybe some Saturday or Sunday. During the course, I will go through the code and the data in detail and explain the key function and parameters and demonstrate how to run the program and interpret the result. So I think it's better to have 3 to 5 students to form one group to do the mini project. Okay, is that okay? 3 to 5. So less student is acceptable, but I do not suggest to have the student less than 3. Okay. It's acceptable, but I do not suggest to do so. And the task for the mini project include these 3. First one, you need to modify the existing code to develop your HVAC management strategy. But I'm still considering whether to add the battery into the system. And the second one is to assess the energy efficiency and visualize the result of your energy management strategy. Also, you need to write and submit the mini project report. The format of the report will be given in the Blackboard when I upload the basic code. I think I currently designed the submission deadline to be 17th March. Okay, so this means that you will have 3 weeks to do the mini project. Before next lecture, please form the groups. Okay, please form your group before next lecture and ensure that at least one of the students in your group brings the computer, because you need to install the Python and Anaconda to run the mini project in next mini project course. And please download the Python from the following website and Anaconda from also the following website according to your operation system. So this means that I will not need to wait for you to download the install application from the website in next course. Any question about the mini project? Any question or any trouble? No? Okay. No, you only need to design your strategy, the rule-based strategy, which is told in this course. Okay, based on the content in today's lecture. Okay, any other question? Okay, so So in today, you have learned the building energy management performance is influenced by the passive and the active factors, a lot of things, the weather, the building envelope, the building energy management operation, and other things. The building energy management systems need to monitor and control the energy related resources, both the generation and the consumption resources, and the devices in the building. The cycling operation set temperature and preheating and cooling and utilizing of renewable energy are some HVAC energy management method for the HVAC. So this is very important because you may need to use this method in the mini project. Okay, this is philosophy, how to reduce the energy consumption of the home energy management system. Also, the backup time varying cost and the renewable energy we consider for energy storage management method. Also, the time shiftable appliance and power adjustable appliance are flexible appliance in the building for energy management. Okay, so these are some rule-based method for the different resources in the building. Okay, thank you for your attention. I think I finished about 3 hours. Okay, if you have any question, you are welcome to ask me after the course, and I will stay here for next 15 minutes.